Okay, my name is Adriana Villela. I am a CNCF ambassador. I'm a blogger, podcaster, and I'm one of the maintainers of the OpenTelemetry end user SIG. By day, I am a principal developer advocate at Dynatrace, and by night, I like to climb rocks, and I checked out one of the local climbing gyms here in Tokyo. I also love capybaras because they make me happy, and I actually had a chance to go to the Happiness Cafe in Tokyo, which made me extra happy. Originally, I was supposed to deliver this talk with my co-speaker, Nancy Chauhan, but unfortunately she wasn't able to make it. But we did put this talk together, so I wanted to give her a big shout out. So we are here because we're talking about the environment. We know that global warming is real. We can't dispute it. We see rising sea levels. We see changes in climate patterns, all sorts of weird things going on. And like it or not, we happen to work in an industry that contributes to global warming. So let's take a closer look what that means. Well, tech is responsible for 2% of global carbon emissions, and that's expected to hold at around 1 to 2% over the next few years, but it's expected to skyrocket to 14% by 2040. Data centers are among the top 10 largest consumers of water in industry, and that includes not just the water for powering the data centers, for generating the electricity to power them, but also the water used to cool them. And then a little closer to home, observability, unfortunately, does have an environmental impact. When you're emitting your telemetry using OpenTelemetry, that is going to have an impact on the energy consumption and the overall global carbon footprint. So it begs the question, how can we make OpenTelemetry greener? And we don't have to change things all at once. Let's start small. So let's start with how about tweaking the OTel collector running on Kubernetes? Now you might be wondering, okay, why do we care about tweaking the OTel collector? And to understand that, let's talk about what the OTel collector does, very high level. So it is used to ingest data from multiple data sources, then it processes the data. It also has connectors and extensions, and then it takes all that data that it processed and sends it to one or more backends at the same time. Now, going back to our original question, why are we starting with the collector? Well, because all that ingesting, processing, and exporting uses up energy. Chances are you're probably running not just one OTel collector in your setup, you're probably running multiple, not just two, maybe a whole fleet of them. And so more collectors means more energy. And at the end of the day, if you tune one collector, we start seeing a cost savings. If you're tuning multiple collectors, well, that cost savings compounds. Now, I want to take a little detour and also talk about the OpenTelemetry operator because it's going to factor into the things that we're going to discuss today. So there are multiple ways to deploy the OpenTelemetry collector on Kubernetes, and one of the ways is through the OpenTelemetry operator. And I want to just give a very high-level view of the operator. So the operator is a Kubernetes operator, and it does two really cool things. First of all, it does configuration and injection of zero-code instrumentation into your application pods. And secondly, it deals with the management and deployment of the OTel collector in Kubernetes. And as part of that second functionality, there's also this really cool component called the target allocator. And the target allocator is basically responsible for decoupling the service discovery and the metrics collection functions of Prometheus so that they can be scaled independently. And there is a reason why we care about that. And specifically for this, we care about the target allocator's Prometheus service discovery functionality. So if you've used Prometheus at all, and deployed it through the Prometheus operator, you'll know that there are two components called the pod monitor and service monitor, and they allow you to scrape metrics from your Kubernetes pods and your Kubernetes services, respectively. And the target allocator, what it does is it says, hey, I'm looking for all the pod monitors and service monitors that match certain criteria, and I'm going to take those scrape configurations, add it to my own scrape configuration, and then I'm going to say, hey, collectors, I'm going to add those to your collector's Prometheus receiver scrape configuration. So it's managing that scrape configuration for you. You don't have to touch it. You have that defined in your pod monitor and service monitor, and boom. So that's a little bit of background. Now, what are we going to use to tune our collector? Now, initially, when Nancy and I thought of this talk, we were thinking, okay, there's a few things that we wanted to explore a little bit further. They were scaling Kubernetes pods, metrics-driven optimizations, and green reviews. And to be honest, we didn't know a whole lot about these things, so we made a few assumptions, and our assumptions in some cases were correct, in some cases were not. So let's dig into these, but before we do, this is the landscape that we proposed. This was our proposed setup. We have basically an example application in a GitHub repo, and I'll share that repo with you later. I'll share a link for that. And basically, it's a Python application that runs a client and a server. It sends OTel data through to the OTel collector, and then we send the telemetry to an observability backend. And so as part of that, we wanted to include some of the tools that we're going to be exploring today in this setup, and you'll see things that worked and didn't work. So the first thing that we're going to talk about is scaling pods. Now, you might be wondering, why do we want to care about scaling pods? Well, first of all, Kubernetes pods take up CPU and memory. CPU and memory equals energy consumption. And so when we're scaling pods, we have an opportunity to save on energy if we're not needing as many replicas running. And fortunately, we have some tools at our disposal to help us with this. First tool is Kube-Green. So Kube-Green is a Kubernetes operator. It shuts down resources when you don't need them based on a time frame. And so in doing so, it helps to reduce the carbon footprint, right? Because if you don't have your pods running, we're not consuming energy. And it has been reported that some of the folks that have used Kube-Green have reported a 30 to 40% reduction in their monthly cloud costs. And that monetary savings also translates into energy savings. So it makes finance people happy and the environment happy. So this is a typical Kube-Green configuration. This is a very simple one that I played around with. So Kube-Green, when you install it, it comes with a custom resource called Sleep Info. And if you notice over here, I've deployed it to a namespace that I called OpenTelemetry. You can call it Bob. And it's saying that any resource in our OpenTelemetry namespace, on weekdays, we're going to put them to sleep between 4:51 and 4:54 p.m. in Toronto time. I'm from Toronto. And yeah, this was a very short period of time because I was just playing with it for a short period of time to test it out. And when I was doing all this exploration, well, I found out, hey, Kube-Green did a wonderful job of shutting down my pods during that time. It did exactly as advertised. But it shut down the application pods, it shut down the application pods, but it did not shut down my OTel collector pods. And I was like, well, that's really weird because the OTel collector, I deployed it as a stateful set. Now, Kube-Green allows you to shut down pods that are stateful set and deployments and cron jobs. Stateful set and deployment is enabled automatically for you. Cron job, you have to enable that yourself. So it fit the criteria what was going on. So I looked in the logs of Kube-Green, and it said, yeah, you know, this OTel collector, it's managed by something else. I don't want to touch it. And I thought, oh, great. There go my dreams. I don't know what to do now. What's going on? I can't use Kube-Green. I mean, it's great for shutting down my application pod, but what about my collector? I want to tune my collector. But when you think about it, it actually makes sense because realistically speaking, my initial idea was, well, I want to put my collector to sleep in my dev and test environments because I'm not going to be using them all the time. But think about it. Your dev and test environments are still the backbone of your infrastructure before you send things to prod. So realistically speaking, you do want your collectors running probably all the time in those environments because even if your application is put to sleep, you do have infrastructure that is still running, and you probably want the collector collecting information on that infrastructure at the end of the day in case something goes wrong and your infrastructure isn't working, right? Because if your test environment isn't working, that doesn't bode well for eventually putting things in production. So then I thought, okay, what now? Fortunately, we have horizontal pod autoscaling to the rescue, and this is managed by our good friend, the OTel operator. So the OTel operator does that management component of OTel collectors. There is a custom resource in the OTel operator called OpenTelemetry Collector, and as one of the attributes, it does HPA. Awesome. So now we can scale down our collector pods based on CPU and or memory usage. Now, fun fact, this I learned because this was new to me, you do need to have a metrics server running in your Kubernetes cluster in order for this to work. Some managed Kubernetes instances will already come preloaded with a metrics server, others might not, so check your cloud documentation to figure out if that applies to you. Now, let's look at what the HPA configuration looks like then for our OTel collector resource. So first of all, there is an autoscaler section, so we specify the minimum and maximum number of pods, and our CPU and memory targets, and those are percentages. Next, we have to set our resource limits, so we have to set the amount of resources that we start off with when our pods start up, and then what the maximum is. And so the HPA uses that information basically to scale your collector up and down. Awesome. The next thing that we're going to look at, so now we've solved that problem for the collector, so super excited. Next thing we're going to look at are metrics-driven optimizations. Now you might be wondering, why do we care about metrics? Well, because metrics tell us information about our system. They help inform us about the health of our system. So we can use the metrics to understand the energy consumption of our system. And again, our good friends, high CPU and memory, translate to more energy consumption. So this is where Kepler comes to the rescue. Now, Kepler is a CNCF project. It stands for Kubernetes-based Efficient Power Level Exporter, which is a mouthful. It basically does some eBPF magic behind the scenes that allows you to convert your CPU usage into energy consumption in joules, and it exports those metrics in Prometheus format. This works out well for our use of the OTel operator because the OTel operator allows us, because it manages the configuration of our collectors, we can use the collector's Prometheus receiver to ingest those collector metrics. Now, to run Kepler, you can install it either using Helm or kubectl. You also, if, for example, you don't have an observability backend that accepts metrics, you can also install the Kube-Prometheus stack, which comes in Kubernetes, which comes with Prometheus, obviously, and also Grafana, and you can even install a special Grafana dashboard for Kepler metrics. In my case, I used an observability backend that did ingest metrics, so I did not need that part. And again, as I mentioned, we are using the OpenTelemetry operator because we're using the target allocator to deal with the service discovery of our Prometheus metrics. And as it happens, remember, Kepler exports our metrics in Prometheus format. It has a service monitor resource, so the scrape configs in the service monitor resource are basically the target allocator takes that information and adds it to the Prometheus receiver's configuration in the OTel collector. Now, after we deploy Kepler, I do want to point out I made a little modification of the Kepler service monitor configuration. Specifically, I'm leaving out a few metrics because they're excessive. We really don't need them. And again, in terms of keeping the environment in mind when tuning our collector, we do want to limit the amount of telemetry that we are ingesting and exporting, because that puts a load on our CPU and memory, which of course drives up our energy and our costs. Now, another thing that we want to explore as part of our metrics journey is internal collector metrics. The OTel collector has the ability to export telemetry about itself, so traces, logs, and metrics. And this is super useful because it helps us understand the health of the collector. And of course, by doing so, it helps us make our collector greener. And the focus for us for today is on memory consumption. So there are a couple of memory metrics that the OTel collector exports that we want to look at to help us understand how we can tune it better. So this is an example OTel collector configuration file, and I'm not going to go through the entire file, so if you want to see the whole thing for yourself, you can scan the QR code on the screen. I'm going to highlight the important bits. So first of all, we are using the target allocator because we want to leverage the service discovery functionality of our of the collector. Of the operator, and so we have to enable it explicitly because it comes disabled by default. And because we want to do the service discovery portion, again, we have to enable that explicitly. The next thing, as I mentioned, I'm running a little application that exports telemetry, OpenTelemetry data, and so I need to be able to ingest the telemetry using the OTLP receiver. And because we are ingesting Kepler metrics, we need the Prometheus receiver. And remember, the scrape configs are taken care of by our lovely target allocator. I also want to do a little bit more scraping. I want to also ingest some Kubernetes telemetry, so I use the Kubernetes cluster receiver, and that uses the Kubernetes API server to give us information about our Kubernetes cluster. And then the kubelet stats receiver, again, uses the Kubernetes API server to give us information about our nodes, our pods, our containers, and our volumes. It's great info. Now, onto the processors. I want to use a transform processor. I'm calling this transform processor metrics. What I'm doing here is I'm converting just the Prometheus naming into OTel naming, so going from the underscore notation to that dot notation. I'm also using the Kubernetes attributes processor so that I can enrich my OpenTelemetry telemetry with some Kubernetes attributes. Now I have this one, and I have another Kubernetes attributes processor. They're for different pipelines, and I'll get into that very shortly. And then finally, I have the resource processor, which enriches our telemetry with our cluster name. So I'm going to skip over the exporter part, but again, if you want to see a full example, you can scan this QR code because we're exporting to an OpenTelemetry backend. Now, I wanted to draw your attention specifically to a few pipelines. We have a lot of pipelines. I have two groups of pipelines, basically. I have the application pipeline, which deals with the telemetry from my little Python application, and then I have what I call my Kubernetes or Kepler pipeline, which is ingesting some telemetry from Kepler that I care about, right? So that we can use that for tuning the collector. And then finally, and the reason why I have two separate pipelines really quickly is I don't want to pollute the application pipeline data with our Kepler data, right? Because it's unnecessary. It just adds to the confusion. And then finally, we have, as I mentioned, we are leveraging the collector's internal telemetry. Specifically, we're leveraging the internal metrics. And I am using a configuration that allows me to send the data directly to my observability backend. However, if you so choose, you can actually send the telemetry back to the collector itself or even to another collector that's dedicated to just ingesting and processing internal collector metrics from other collectors. Very meta. Then the final thing that Nancy and I wanted to explore as part of this are green reviews. I'll be honest, didn't really know what green reviews were about. I read the documentation. I'm like, this is still really confusing. Nancy connected me with one of the folks working on green reviews, and she answered a few questions, so now I understand it better. So what are green reviews? Well, they're not a mitigation process. Instead, they're used to inform us of the energy consumption of our projects. And the idea is when you release a project, every subsequent release, hopefully your energy consumption goes down. You don't want it to go up. You want it to at least stay level, stay the same. But realistically, you want to be able to use that information so that, oh, you know, release 1.1 had more energy consumption compared to 1.2. Great, we're seeing an improvement. Or 1.2 used up more energy than 1.1. We should go back and tune things and see what we can do for it to consume less energy. And interestingly enough, it turns out that it uses tools like Kepler to help us with that information. Now, based on all this stuff that we learned, Nancy and I decided to put this into practice so that we could actually try this out and speak more intelligently to it. And so we decided to try out a couple of things when tuning our OTel collector. So first of all, we thought, hey, let's split the collector into two. Remember, we have two sets of pipelines, one for our application and one for our Kepler telemetry. So we thought, okay, what happens if we do that? And then the other thing that we tried was, what happens if we build our own custom collector distribution? So it is considered good practice to build your own custom collector distribution because oftentimes the collector contrib image has more than enough stuff that you probably don't use, more than 75% of it. So you end up with this bloaty image. So we thought, well, what happens if we built a custom image? It's a lot smaller. Will we see an energy savings as well? Now remember, these two tests were done separately. I did not change all of these things at once because the problem is when you're tuning things, if you change too many things at once and you see an improvement or see things get worse, you don't know what it is that caused the change. So always, always just change one thing at a time. So what did we measure in this? Kepler has a metric that it exports called Kepler container joules total, so we measured that. We measured a ratio comparing our baseline to our changed thing, and if the ratio is negative, that means that it has gotten worse. If it's positive, we have seen an improvement. And then the internal collector metrics, there are a couple of memory metrics that we were measuring so that we could see if we saw some sort of improvement. So if there's an increase in memory, obviously that means it's using up more energy. So here are the results. Drum roll, please. First of all, when we measured the two separate collectors, the green is the baseline, and then the white and the blue are the two separate collectors. So as you can see, because the two separate collectors are processing less stuff, they use individually less energy than the baseline. But then you're thinking, yeah, but it's two collectors, so not really. And you're absolutely correct, because in the second graph, the top line represents when we combine the two collectors, the energy output of them, and the bottom line is our baseline, because we're running two replicas, right? Two replicas use up more CPU and memory, so this is not very surprising. Now, when we look at our ratio, we see that it's a negative number, and it's a pretty large negative number, so not surprised. That proved what we were seeing in the graphs. And then finally, we looked at the two memory metrics, and here we didn't see much of a change, to be honest, so which is a little bit surprising, but these things happen. So not much of a change in memory. Then now let's look at our second test that we ran. So in the second test, the white line is our contrib collector, and the blue line is our custom collector distribution. And you can see that it looks like our custom distribution did a little bit better, and our ratio is positive. It's not a huge positive number, but it's like a bit of an improvement. But where we did see improvement was actually in the memory consumption. So the white line is our contrib collector, so our baseline, and the blue line is our collector distro that we built. And you can see the collector distro uses way less memory. Why? Because you've got less stuff running in it, stuff that is unnecessary that is running in your contrib image. So awesome. We learned some cool things about this, right? So based on this, we've gathered some collector tuning tips that we'd like to share with you. First of all, use metrics to guide you. We have Kepler metrics and we have internal collector metrics. Use custom collector builds, because even though we didn't see a huge improvement when it came to our CPU usage, we did see a huge improvement in the memory usage, and that will translate to energy cost savings. Also limit replicas where possible, and interestingly enough, we saw that also when we were splitting our collector into two separate collectors. I mean, in some cases, obviously, you do need to run more than one collector, so what can you do? But try to limit it as much as possible. And using horizontal pod autoscaling can definitely help inform you of that. And finally, limit the amount of telemetry that you are exporting and processing, because that is also going to have an effect on your CPU and memory usage. It means, it doesn't mean let's not collect telemetry. Let's try to figure out what telemetry is important to us to collect. Now, what are the lessons that we've learned from this little tuning exercise? First, experiment, try your assumptions. I thought, hey, what would happen if I ran my own custom collector build? Would we see any energy savings? Guess what, I tried it, yay, I learned some cool stuff. Secondly, don't change too many things at once. Only change one thing at a time, because as I said before, if you change too many things, then you won't know exactly what made things better or worse. Don't rely on just one test. Run this multiple times, because otherwise, what does one test tell us, right? Statistics, right? Tuning is never done. This is an ongoing process. It's like, oh, I tuned this release, great. The next one's gonna be just as good. No, you don't know that. Even in the middle of working on a release, things may change, you never know. Be prepared, there's a large learning curve with these tools. I didn't know any of these tools before. I was a Prometheus novice back in the day, still am a little bit, didn't know anything about Kepler. I had a lot of help from the community, which helped me understand a lot of this stuff. And don't expect a quick fix. Implementing these tools is not going to magically make things greener for you, but it's definitely going to put you on the path. If you're looking for additional resources to look into making things greener in your setup, consider looking at build packs, choose greener data centers. Fun fact, the greenest data centers in the world come from Sweden, of all places. Very cool. And then look at kube costs to monitor and reduce your Kubernetes spend. And this is a diagram of the sustainability landscape. This is a direct copy of the diagram that you can find on the QR code on the screen. We just made it look a little bit prettier, but take a picture of that to scan the QR code, learn more about it. And then finally, I wanted to leave you with some pieces of advice from experts. So Nancy actually went and interviewed a few experts, gathered some of their words of wisdom to share with looking at things that we can tune further. So first of all, my coworker and teammate Henrik Rexed said, identify the working hours of the environment to turn off your application during night hours. That makes sense. If your application isn't running, why have it, if you're not using your application, why have it running, right? We mentioned that earlier. Regularly audit everything that's running, right? Because things can change, you never know. And then GPU waste is your biggest leak, so keep that in mind as well. And then remember that reducing carbon footprints is not a sunk cost. We actually can equate the reduction of carbon footprint to cost savings. So that makes everyone happy. It makes the earth happy. It makes finance happy. And now I wanted to leave you with some final resources to check out before we go. First, there is a link to the Kepler project. If you want to learn more about this, I have a link to the GitHub repo where I played around with this stuff ad nauseum. I use GKE as my environment for setting up all this stuff. There is a link to the cloud sustainability landscape. I also wanted to link a video from my coworker, Henrik Rexed, who, as I said, this is the power of community. He's done a lot of work around this, so it really made it so much easier for me to understand this material so I could share it with you here. Also, along the way, I had never done my own custom collector distribution, and I ran into some stumbling blocks, so I wrote a blog post about it in case you run into similar stumbling blocks. Hopefully it'll save you some time. And then a link to Tag Environmental Sustainability, which I think that link might be out of date because I think Tag Environmental Sustainability might have gotten merged with another group. Just keep that in mind. Also, I'm going to do some shameless self-promotion. As I mentioned, I do have a podcast. My daughter helps me run it. She edits the videos. The capybara is my mascot, so you can imagine how exciting it was to play with one in real life here. I've had some really cool guests on the podcast, including Kelsey Hightower, a number of CNCF ambassadors, like Whitney Lee, Marino Wijay, Nancy, my co-speaker was also on my podcast. Had Charity Majors, Liz Fong-Jones. And also, if you're new to OpenTelemetry, want to learn more about observability with OTel and like video courses, I do have a course on O'Reilly. And then next week is OTel Community Day, which is taking place in Denver in the US, just at the tail end of Open Source Summit. So if you're around for Open Source Summit, just make sure you check out OTel Community Day. And I also want to give a shout out to Nancy, who unfortunately couldn't be here. She just completed her master's at Cornell University, and she is looking for new roles. So if you know of anyone looking for an awesome developer advocate, give her a shout. And thank you so much, arigato. It's been a real pleasure. Thank you so much for coming to hang out this afternoon.